Right, hello. This is a quick demo of the ELEC351 coursework, and apologies for the webcam quality. It's fairly late and quite dark, so I've had to improvise the setup a little bit. But so we'll go through each file in turn. I'll explain a little bit about each function, how it works, general thought process, and give a slight tutorial on how to run the code. Um, So we'll go through main first. So initially, we're going to reset the LED strip. As you can see, there's no lights on it or the 7-segment display. That that function is purely just write a 0 to all parts of the LED strip and clear the 7-segment display as a built-in function of part of the Plymouth library. Next, we'll initialize our threads. So we'll have T1 is going to be used for measuring data. T2 is going to be used for managing the mailbox. And T3 is just going to be for monitoring terminal inputs. So as you can see, at like any point during the code, you can type to it and it won't cause an issue. Um, this ticker, T3 ticker, that's essentially for where the data is being measured. It's going off of a semaphore, so this is being used as an interrupt, as a continuous interrupt to re-enable um, the release and acquiring of the semaphore. So then the next function is just setting an initial date time for the LCD. So as you can see, we've got I think it's in reverse, but you can just about make out it is pretty much now. I've you set that manually, so I've just gone through here and set each month, day, hour, and etc. Then this function, which is setting up the interrupts, I'll go through that in a little bit more detail in the file because that's quite a large um, document. Uh, Next is just enabling the LEDs, set it like getting a current timestamp from the RTC, and then setting it to the LCD. Um, then next we're going to be going through each thread, starting, as I said earlier, T1 for measuring data, T2 for mailbox, and T3 for monitoring the terminal with the ticker attached for the semaphore. We're also measuring the data on the highest priority thread as per the requirements. Um, and then we'll just do another set time just before we start the while true. So this loop is where the code is just going to be permanently, because it's just going to be monitoring for a button and press and then updating the LCD. We've got the threads joining, but like the comment says, it'll never reach it just because of this while loop. So the next script is going to be the buttons. So these 4 variables here are just the flags for each button being pressed. I could have gone down the route of just having one flag, but just purely for the sake of if you tried to hit 2 buttons at once, I thought that might have caused an issue, so I just made it simple for me by having 4. I've also got a debounce period for each button just to ensure there's no double presses, essentially just acting as hysteresis. Um, this current field, that is what prints to the terminal if you press a button. So as you can see, I'm cycling through the fields, basically the day, month, year, and then hour, minutes, seconds, and then you can increment those with the other 2 buttons. So then our buttons are being set up as interrupts. Then the setup button interrupts is just saying on a falling edge, run the interrupt service routine. I've got 4 timeouts for the debounce. So that's essentially my thought process was for the ISR to prevent blocking, just disable the IRQ, reset the flag, or sorry, set the flag to say the button's been pressed, and then sorry, because then this will get checked in that main loop. So here, so it's going through. If a button's been registered, it will do a computation just to keep the ISR as short as possible. And then after that debounce period, it will re-enable the IRQ. That's the process for every button. But these functions here for enabling the IRQ and B, that it's just I just made it because this attach, it needs a function call as the first parameter, which is interesting. So this is a little get around to that. Um, Yep, all of these ISRs are the exact same. Just setting the flag, and now the button press function is the main one that's called in main. This essentially just checks which button has been pressed. It will reset the flag for each of them and do the appropriate action. So in the case of button A and C, that will increment or decrement the structure of the time that was in the init time function I showed earlier. So that will just be whatever field you're in for, and the field is the buttons that cycle through. So B and D, it will increment whichever one it's in with a small little error check for preventing infinite like months and days. It's just assuming each day has got 31 days to it, and yeah, that's a little check, and then at the end of it, it'll update the time, just so then you can actually see it going up on the LCD. So I am now in field 5, so you can. Oh, but it's not very good. Bit, and let's see if we can show it properly. There you go. So you see, I'm now cycling through the months. That's an easy one to spot changing. And that's the same for the other decrement button as well. Just the error check's a little bit more simple with just ensuring it's above 0. But then the other two buttons, B and D, that is just, as you can see from the terminal here, as you press it, it's just cycling through it, and it can wrap around. So that's the button handler C file. Then the header file, fairly simple, just enabling the use of these functions in external files. Now the LED strip, this is a class, and it's been sort of optimized to use an API approach. So there's one public function, which is just the setting of the LEDs. The scale value is private, so the user only has access to set LED because it does everything for them. But so the constructor is declared globally, and it's purely just saying which sensor would you like to measure, that being light, pressure, and temperature, and then it takes a copy of that to be a private variable. So then the scale LED, the scale value function will just go through whichever input was provided, and it will scale it to be in an appropriate range. So temperature is 0 to 100 degrees, and that's represented across the 24 LEDs. The pressure, I did originally have it as 1,000 here, but that meant all LEDs would be lit up due to 1,000 millibar being normal atmospheric pressure. So this 2,000 just puts the LEDs to the halfway point, so you can actually see if there's an increase or decrease. Then light is just it's 1 to 10, so it's purely just being scaled by 24. So then this is the next public function. So this setting of the LEDs, you will pass in the sensor value, and due to the scaling which is set in this function, which is the private function, all you have to do is pass in your sensor value, and it will handle it accordingly. This binary number is it's shifting it by how many LEDs should be on, and then subtracting one. So as you can see from this little demo, it just it can it just gets it into a binary format for the writing. So then it will write the sensor value to the 7-segment display. Then this binary number is going to be used here for the writing of the strip. So it's the shifting is just for each bit, because it's a 24-bit number. So we're just shifting it by 8. So then you can get the second set of 8, which is the green section, and 16 for the blue section. Here's just the little error check. So you can see if for the temperature and light levels it gets below 5 or above 18, it will play the buzzer. I've done it slightly differently for the pressure, just because it would always be beeping otherwise, and it would never actually be able to hit these, or if it did, I think you would be in trouble. But then this void LED off function, that's what I showed at the very start. It's resetting all of the strips and the 7-segment. It's not a part of the class, but I felt like it should be in this header file because it's being used by all of it. Then the header file for that class is fairly straightforward. It's just you've got the function for the LEDs turning off, and then the class for the strip has got its private variables, the private function, and then the constructor and the public setting LED function. So the sensor measurement file is it's handling all of the sensor readings, so it'll have your mailbox, and the actual sampling of the sensors itself. So to start with, we've got the standard atomic bool, which is just an atomic flag basically. So it's just, I put it there for safety so that it can't be tampered with during execution, just to be triple sure. So each of these flags, is for the terminal commands. So this sampling is just controlling if it should be on or off. The flush flag is just for, do you want to write all your samples straight to the terminal? I'm just going to reset that so it doesn't go endlessly. And the same thing for these flags here, which are just for which sensors should be being read. Don't actually need this standard, so I'll just remove that quickly. Now, so this semaphore is used for the sampling period. I'll talk a little bit more about that later. And then the terminal string is just whatever the user's going to input. The mailbox is of type data, which is the structure. So if I show you that one. So here, this is our data struct. So it's just got the temperature, the pressure, the light level, and then a time structure. So then when you call the member function update, it will get new readings and get a new timestamp. So then going into the mailbox, we've got just the sample count, which is local, so it can, as you probably saw earlier, it writes to the terminal and it'll give you just which sample number it is. I've made. Oh no, we're not there yet. So I've got this while true, so it will constantly be checking this, which is on thread 2. So it's waiting for data from the mailbox, which is blocking, but because it's on a thread, it's allowing it, well, allowing other threads to do their tasks. And then if the message received is valid, it will then take a copy of the message and put it into the the array. No, so not array. The just the variable message, which is of types data. Um, so it will save that reading in the samples array, which is indexed by the sample count, and then it'll increment it, and then afterwards it will free the message, and then it will do a check for if the sample count is the mailbox size, which in this case is 10, or the flush flag from the terminal has been set. It will write it to the SD card, reset the counter, and reset the flag. So then going on to our measure data function, which is again is on another thread, and it's permanently blocking. But this semaphore was put in because I originally had just an if check for if the sampling flag, but because it's on the highest priority thread, it will just brick the code the second you turn off sampling. Like it would just you couldn't do anything else. So this semaphore will fix that by it'll check for it, and it'll block it here, and again it'll just allow other threads to loop around. So if the semaphore can be acquired, it will take an update of the data, which is each thing plus the time. It will check which flag has been typed into the terminal. If not, it will skip it. But if there is one, it will set the LEDs with its respective data. After that, it will try to allocate memory for the mailbox. If it can, it will copy the sensor's data into the mailbox and put it in there. Otherwise, it will print could not allocate memory, which I'll go through now actually. So if I change the sample period to be a really low number, so we were originally at 10 seconds, and this is now at 10 milliseconds. I'll do a quick build, and you'll see that the speed at which it's trying to allocate and deallocate the memory, it cannot cope with it. So that's just a little trick I found while I was programming it. Just I left it in there as a little tutorial piece. So this is going to be quite quick. So we'll try and pause it. If it ever wants to build, here we go. So you can see that the speed it's going, it's every single message. It just can't do it. So it's just not working at all. So we'll go back to how we had it. Right. So after that as well, it will sleep the thread for the sample period, just to avoid any memory and no, not memory, just power problems. It's more power efficient. So this is the ISR for the semaphore. So if the sampling flag is on, which is in the terminal, it will release it. Otherwise, it will just hold it here. So that's how I've stopped the sampling, which I can do a quick demo of. So if you type in sampling off, this is case sensitive, as I've just messed up. So you'll get a little confirmation message when you've typed in a correct command. So as you can see here, it will stop the sampling. We're on the 10-second period at the minute, so it'll be hard to tell, but it does work. I'll show you briefly and then talk about some other bits while we wait. So I've now just changed it to a 1 second sampling rate just for demo purposes, so we don't have to sit here for 100 seconds before the SD card contents are printed back to the terminal. There we go. So if I just let it to do a set of samples so you can see it's working. Here we go. So we've got 10 samples, and then if I turn the sampling off, and then we wait a few more seconds, it won't print anything. So what's printing to the terminal is the contents of the SD card. So if sampling's off, it will not be printing anything because it's not receiving any samples. Turn the sampling back on. Here we go. So now we can see it's coming back through all the contents of the SD card, and then if I type in flush, it will flush on the next sample the however many it's had. So we'll see it's printing out quite a few here. So if I restart it, just so it's got less samples, see there we go, flush. So it's only got 2 samples. It's just printed those 2 off. I'll do a quick demo of the LED strip. Actually, I should have done that earlier, so my apologies. So if we type in select select L, can't type today, obviously. Here we go. So we're measuring light now. So you see each sample that goes along, it's this strip is changing. So if I get a little bit more light on the LDR, you'll see the light decreases. Likewise, if I get it longer, it's lighting up all the way. A buzzer is sounding, but I don't know if you can pick that up on my microphone. So then I'll show you temperature. So this is now temperature is 0 to 100. So as you can expect, my strip hasn't passed the first one because it's at roughly 21 degrees in here according to the 7-segment display. And then pressure, we're roughly at the halfway point, which is what we expected because I've divided it by 2000, so normal atmospheric pressure would be halfway. Then the next function I've got is the monitoring terminal. So this is being run through a thread. I'm just going to change this back to 10 seconds quickly so we're not watching all these samples go. So this is just going to be monitoring what the user types in. So I've used standard get line, which just allows me to take the user input with white space. Otherwise it just goes a bit weird. And then it's the string that's typed is what the result gets saved to. And then here we go, it just prints out what you've typed so you can see if you've been silly like me and can't spell. So each function that's typed in, little bit messy because my definitions here for the comparison string. I've just listed each one out. I was messing around with like reg expressions where I can just have wildcards in like this and just compare this, but it just seemed like more hassle than it was worth. So I've just made, for simplicity, each string that's going to be checked with is going to be checked with case sensitive, and it will just run through and check each one. And if it's met, it will set the corresponding flag and print a confirmation message. So for the sensors, it's a little bit more involved because I'm just disabling the other two just in case, and then enabling the respective one. But with the atomic library as well, it's slightly different. So you just got to do your flag.store and then give it the value. So it's the exact same as just saying sampling flag equals false. And now we're on to the SD card section. So I did have this. I was trying to put it into another file, but there was so much relied upon. It was quite complex, so I've just left it in the sensor measurement as they are all related. So this flag here is for the first time run. It will just clear the SD card file so that you don't get endless amounts of data coming through. But for the write SD function, then this part here is that first time run. So it's just if it can be reset. Oh, sorry, if the flag is set, which is it's always going to be on boot up, it will write to that file an empty string with false in the append slot. So it's just going to clear it, and then it allows it to write to it. It's got a little error check for if it can't do it as well, but I've never seen that. And then it sets the flag back to true to say it's been reset. But going back to the other section, this buffer here is it's used alongside the mailbox, so I could have had it or just used the mailbox, but just for my sake, I've made another buffer just so I can sort of picture each sample coming in. It's getting copied across to this separate buffer, and then gets printed off. So I've initialized it with the total string length being 110 characters, and then I'm timesing it by how big the mailbox is. So this string here can be flexible on the size of the mailbox, really, because this is always going to be the same. So it will loop through for however many samples we've got. It will store the time in its own separate little buffer, which this is all just the part of the provided code. I've just modified it by adding on the seconds here as well. So it's copying into the time buffer how big it is, and then in this format the time structure from this section in the samples array. And then it's doing a similar thing with the sensor data. So here we're printing out in this format, which you can see here, with each sensor plus the time, and then this is just appending the sample data. And then if the SD card is inserted, this is just a little error check to say it can do it, otherwise it can't write. Or if there is no SD card inserted, it will just print out there is nothing there. And then this is the header file for it. So it's just got the definitions of the strings, the sampling time. So I've given you a little demo one here, so you don't have to sit here for 100 seconds to get all your samples. And then this one was the demo I had earlier for the the mailbox size just failing to allocate. Here you can set the mailbox size. I'd leave it at 10 just because I had some issues with larger mailbox sizes. I'm not sure if that was memory related or what, but I've just had 10 as a since the beginning, 10 samples. Um, and then here was the data struct, which I've gone through already. The function definitions with the variables as described earlier. And the time manager, fairly straightforward. It's purely just setting up the time and then printing it to the LCD. But this will basically just get a current reading from the RTC, create the structure, and convert it into a string. So then it will clear the LCD, make this buffer, and then this will just print it onto it. So it will locate the top row, print out the date time or the date, and then locate the bottom row and print out the hours, minutes, and seconds. And then it will sleep for a slight period, because if you didn't have this, it would be updating so quickly you wouldn't be able to see the seconds. And then the time manager header file, it's just the structure, the date time, and then the two functions, init time and control LCD. But yeah, that was a quick demo. Just see if there's any other functions I've forgotten, which I don't think there are. So I think I've demoed now everything. All functions. You can see how they work, how the SD card writes. It's at the end of each like sample period, so it will take 10 samples to write back because it's reading the contents from the SD card. It works for all sensors. Deadlocking's been minimized because there's never going to be accessing anything more than once. The semaphore is the only real requirement there, just because it's on the highest priority thread, so that's preventing deadlocking. But any other variables are safe. Right, yeah, that's it.